Hi, my name's Breck and I'm the founder and CEO of RowZero. This video is going to be a deep dive on RowZero's Python capabilities. This is for more advanced users who already know Python and are trying to better understand how they can use Python to manipulate data that they have in a RowZero spreadsheet. So let's get started. I'm going to open this Python code tab by clicking on that, and we can see there's already a function here called foo that's like a hello world function that just says hello plus whatever we pass into it. So let's invoke foo and see what happens. So I'll put some data in the sheet, row 0, and I'll say foo of row. And I get this error that function foo is not found. And it's not found because foo is not yet in scope, because I haven't yet run the Python code window to bring it into scope. So I could do that by clicking the run button, or instead I'm going to press shift enter, just like I would in Jupyter. And now foo's in scope, and as expected, we get hello row, and if I copy that down, we get hello 0. So it makes sense. So there's some type conversion that's happening as we go from spreadsheet land to Python land that I'd like to drill into. And here we did it for a row 0 text type, which got converted to a Python string. But let's see what happens for the other row 0 primitive types like numbers and dates. So I'll delete this, and let's get some different types in here. So we'll put a number, put a date, and we'll put a date time. And we sort of intuitively know that these are different types in the spreadsheet, but we can actually find out exactly what their type is by using the kind built in. And this is not something a regular user would ever use, but it helps us introspect on the actual contents of the spreadsheet cells. And so we can see we have text, number, date, date time. Those are the core primitive types in the spreadsheet. So now let's try to understand how these things are getting converted as we go into Python land. And we can do that by using standard Python functions. So there's a function in Python called type that'll tell you the type object of X. And if I do stir of that, it'll tell me the name of the type of X. So I'm going to press shift enter to modify foo. And now I'm going to invoke foo on these different types. And as expected, I get a Python stir for row. When that crosses from spreadsheet land into Python land. And we get the other expected types, float, date, and datetime.datetime for these values. So yeah, there's the seamless marshalling that's happening that's pretty easy to understand from spreadsheet types to their corresponding Python types. So now let's see how it works for more advanced types, like if I pass in a whole spreadsheet range reference or a whole row 0 data table. So to do that, I'm going to delete those guys, and I'm going to put some numbers in the sheet. And I'm going to, again, invoke foo over this whole range. Now when I hit enter, I see that the type of this is a sheet range iterable. Now this is like a made-up type that row 0 created to receive a range reference from spreadsheet land as it crosses into Python land. And there's really only one thing you can do with it, and that's iterate it. And as you can see in the name, it's a Python iterable. So what I can do in foo is now I'm going to change this to say for value in X. I'm just going to loop over these values. I'm actually going to print the value to standard out, and then I'm going to return 42 when I'm done. And so now when I press shift enter, return outside, and that's because my indentation is off. So now I'm going to press shift enter, and as expected, it prints 1, 2, 3, 4, 5, 6 to standard out, and then we get the number 42. So you may have values in sheets that you want to iterate over in Python. This is how you do it. A more common way that we see to pass values in bulk into the spreadsheet is to pass an entire row 0 data table from spreadsheet land into Python land. And row 0 data tables, which are the output of things like pivot tables or connected tables if you've imported data from Snowflake, Databricks, Redshift, or Postgres, those data table objects get converted to data frames. in Python land. And so let's see how that works. So I've already got my numbers. Let's add a couple more columns that are interesting. So we'll do some text, and then we'll do another date column. Copy that down with Control D, and let's give these things some headers, numbers, text, dates. And I can turn this into a data table using the data table built in. So if I say equals data table, I grab this whole range, and then I'm going to say has column headers true. And now I get a data table that represents the data that's in these ranges, and this like live updates. As I type here, you can see the data frame, the data table also updates. And so I just called this a data frame, and that's really how you should think of it. So in row 0, the values in a cell can be numbers, text, date, or date time, as we've seen, but a single cell can also contain an entire data frame. And that's what's happening here. The value of D13 is this entire data frame. And the data frame is sort of spilling out of D13, and we're getting this X-ray view into the contents of it. But all the values are in D13, and we can prove that to ourselves by, for example, creating a reference to, let's try to reference A here. So we'll go to E14, and we don't get anything. We don't get anything is because there's nothing in E14. The data frame is here. And this gets a little bit more obvious if we cause the data frame to collide with something. So for example, if I put a value here and I expand it, and then I let go, now we can see the data table can't spill because it's colliding with this value here. If I delete this, it spills again. So that's how to think about it, is D13 is an entire data table. And we can convert that to a data frame in Python land by doing, by just passing it in. So let's get our type helper function again. And now I'm going to say foo of D13. And what we see is that this is a polars data frame. So polars is a popular data frame library. It's similar to pandas, and there's seamless conversion from polars to pandas. So I can just say x.toPandas. And when I hit Shift Enter, now I can see that the type of D13, the type of this data table, as it was translated into X, is a pandas data frame. And I can do any data frame operation on this that I want. So for example, I could return, well, let's like give ourselves some better variable names. So we'll say x.toPandas. So that's our, this is a pandas data frame. And now I'm just going to return df.head like that. And that collides with my previous formula, but when I delete that, I now get, as expected, the first 5 rows of my original data frame. So you can kind of seamlessly go from these row 0 data tables into Python land. You can manipulate the data frames in Python using either the polars API or the pandas API, and then you can return new data frames or any Python type from Python back into the spreadsheet land. And once the data is over here, I can do all the regular spreadsheet things with it. I can do pivot tables, I can graph, I can write countifs. It's common in kind of bigger workbooks to see data flows where data is kind of like weaving in and out of spreadsheet land to Python land and back. So anyway, that's a quick overview of row 0's Python capabilities. Give it a try, and please reach out if you have any questions. Thanks.